Hi guys, it's John again, and today we're going to be setting up an ScPrime miner on a Windows PC. So quite a few people requested a Windows version of the Raspberry Pi video, so that's what we're going to be looking at today. Now, the reason I've gone for a small dedicated PC here is because you want to be able to leave your computer on all the time. You don't really want to have a big desktop PC or laptop running all the time because it's just not very power efficient. So I have actually already tested this, and with everything plugged in, this only uses about 20 watts of electricity. So over a year, that's going to use about £30, which is around $40. And per month, that's about £2.50 or $3.40. So this is probably one of the cheapest ways you can do it. Rather than leaving on a big desktop computer where you've got graphics cards and big power supplies running, this thing will do the job just fine. So anyway, what is ScPrime? Well, it's a way of getting paid for sharing your storage space. So as you can see over here, we've got a couple of hard drives. And what we can do is actually set these up to be shared on the ScPrime network with our storage provider here, and we will get paid for meeting the incentives of the project and obviously providing value to the system. There's a link in the description if you want to check out ScPrime. It's quite an interesting project. Now, as we discussed in the previous video, you can actually buy miners from the XA Miner website. So anyway, I'm not going to go through too much more. We're just going to go through the actual cost of this setup here. So I have put Amazon affiliate links in the description below if you want to pick any of these up. These are the ones I recommend really as a sort of minimum baseline to setting up your node on Windows at least. So we've got this Beelink mini PC here. I've never heard of Beelink before, but everything inside it is pretty standard basically. You get a Intel quad core, which runs up to 2.7 gigahertz. It's got 8 gigs of DDR4 RAM. It's got 128 gig M2 SSD, so that's nice and quick. And it comes with Windows 10 Pro. So this costs £169 and 15p, which is $229.94. So for the price, I mean, £169, you're looking at £169 just for a Windows 10 Pro license. So the fact we've got a whole computer here is pretty good. We've got dual HDMI outputs, wired Ethernet, USB 3, and we've got some USB 3 on the front as well. So storage wise, you can put as many terabytes of storage on your node as you wish. Here is a 2 terabyte Seagate drive. So this was $57.89 or $78.70. And what we're going to do is just do some playing around with adding folders and adding additional drives to the system to just see how it's done. It's a bit different in Windows, but it's not too difficult really. But the big boy here is an 8 terabyte external USB drive. So this thing here is actually £126 and 65p, which is $172.17. So 8 terabytes is a nice size to go for, I think personally. You can obviously use as big a size drive as you like, but here I've got an 8 and a 2, which makes 10 terabytes in total. Now here we have a cool and hip USB flash drive. It's a neon colored one, but basically this is the cheapest 128 gig one I could find at the time of this video. So this cost $8.99 or $12.22, and this is going to be our backup drive. So my thinking with this setup is we're going to have everything on one of the fast drives, either the 8 or the 2, and it's going to be a completely self-sufficient setup. So if for any reason our PC here dies, what we'll be able to do is just grab our disk or whichever one we put the metadata on and plug it into a new Windows computer and just double click and sort a few things out, and we'll be back up and running in no time. So that's the aim with this video. I've put time codes in the description obviously if you want to jump to any specific part. Please don't forget to like and subscribe as that's really appreciated, but let's carry on now and get this thing set up. Okay, so here we are on our mini PC, and this is how it's set up currently. So I've only plugged in the 2 terabyte drive to start with, which is the P drive here, and we've got the Z drive, the USB pen drive or the backup drive over here. So we'll add in the 8 terabyte disk as well a bit later on, but I just want to keep this as simple as possible to start with. Again, it doesn't matter what size your drive is that you're starting with. I've gone for 2 terabytes. In my previous video, it was 5 terabytes. And after we've added the 8 terabyte drive, we're going to have 10 terabytes in total. So we'll just start off, like I say, with the 2 terabyte drive, and we'll go from there. So the first thing you want to do when you are in Windows is the drive you want to enable for ScPrime. You want to right click on it, go to properties, and here we want to enable compress this drive to save space. Tick that box and click apply. Leave it as the default. Apply changes to P drive and subfolders and files and click OK. Click continue if you get prompted, and you can then just press the OK button afterwards, and we've now enabled compression on this drive. This just speeds things up when ScPrime is sorting out its folders that you add in for storage space. We don't need to do that on the Z drive for the backups. We can leave that as it is. So we've got a drive almost ready here, but what we're going to do is go inside it, and we're going to create some folders in the side. So the first one we're going to create It's going to be called ScPrime. We're going to create another folder in here called MetaData. And next we're going to create a couple of folders called data. So we're going to have data 1. Then we're going to have data 2. So basically, ScPrime is where we're going to be storing the application itself. The metadata is where it will store its metadata. Data 1 is going to be 1000 gigabytes or 1 terabyte of space, and data 2 is going to end up being around 850 gigabytes of space. This is because they recommend you keep 100 gigs free for the metadata and also 50 gigs free for the drive itself, just so it has room to work and function properly without getting filled up. So if we come back out of here, we can see Windows is showing this as 1.81 terabytes. That's just the way it's being calculated. We can see here quite clearly that the free space is definitely 2 terabytes in bytes. So don't worry about Windows rounding down here. You have got your full amount. It's just the way it's being displayed. So that's our disk configured. So now we can download ScPrime, get it inside this folder here, and then get it running and then start configuring it. So we're going to go to the ScPrime website here, scpri.me, and then we're going to go to resources, software, and here we're going to download the command line version 1.60 for Windows. Okay, so once that's downloaded, just click on open file and we see our ScPrime software here. We can close the browser. And what we're going to do is go inside here. We're going to drag all this across to our ScPrime folder on our USB disk. Once that's copied across, we are good to go. Okay, now we need to open up the command prompt window. So there's many ways you can do that in Windows. You can click start and just type CMD and press return. You can type command prompt, you can type the whole thing in if you wish, but we'll just keep it as simple as possible. Right, so we have our command prompt window open, and now we want to browse to our P drive where we stored our ScPrime application. So if you remember, we stored it on the P drive here. Now your drive letter might be different. It might be D, it could be E, F, it could be anything. I've just set mine to P for prime. So I'm going to go to the P drive now by typing P:, press return. We're now in the P drive. We can type dir and have a look. We can see here the folders that we created, or the directories, data 1, data 2, metadata, and ScPrime. So we know that ScPrime is inside this folder, so we can do a cd, change directory to ScPrime, press return, and then just type dir again, and we can see here we have our spc.exe and our spd.exe. So now what we want to do is start up ScPrime, but we want to specify where we're going to store our metadata. So remember, we created the folder up here, so metadata. So what we're going to do is tell spd.exe to use that folder for its metadata and put all its files in there. So to do that, we're going to type spd.exe -d and then the location of our metadata folder. So we know in my instance here, it's in P /metadata. Now again, yours might be on a different drive letter, so just change P for whatever drive letter you have got. After that, do a space and then -M and then GC TWH. Okay, just press return. You'll get a notification here from the Windows firewall. We can allow that, that's no problem at all. And now we're going to be sorting out our metadata and getting it all ready on the P drive. Now, if you want a bit more information as to what's happening whilst you're waiting, you can actually load up another command prompt window and run a command to check it. So I'm just going to right click, just going to open a new command prompt here, and we're going to go into our P drive again. So P:, go into ScPrime, have a look inside, we can see SPC is here. So we're going to type SPC, and we can see here the result. We can see synced is no, the height is 4190. So we need to wait obviously for the height to reach maximum, and then it will be in sync. So like I say, you can keep on running that if you wish, but basically you need to wait for the blockchain height to reach this number here in the ScPrime Explorer. So scprime.info, and you can see here the current height. So you can keep on running SPC every now and again. It's going to take a very long time to complete, so at least overnight, if not longer. Mine took around 20 hours, as you'll see once it finishes. I'm just recording this to add some additional information so that you can understand that the blockchain height must be met before you can proceed to the next part of the video. Okay, so a day has passed almost, and we've now finally finished syncing our metadata. So you can see here it took a good 72,358 seconds, which is just under or just over 20 hours. So it's going to take a long time to sync your data. Think of it as when you sync your Helium miner to the blockchain, it does take a good day or two to actually fully sync up. So we can test that we're synced up by just typing in, we say SPC, and we can see, yes, we're synced, and this is the current block height. So now we can actually continue with our setup. Okay, so what we want to do now is create our new wallet. So again, we're still in our ScPrime folder where we have our SPC and spd.exes. So we're going to just type SPC wallet. And don't forget you can do a /? and hit return, and you can get all the available commands here. So we can get our address, we can get a balance, we can initialize, you can link up your existing wallet if you already have one. And you do need to use a separate wallet for each node. So this is only if you're reinstalling your node for some reason. You can send your SCP to another wallet address and unlock it and view all the transactions. So these are all the commands available for the wallet. So we're going to do an SPC wallet init because we want to initialize and encrypt a new wallet. So we're going to just type SPC wallet init and just hit return. And then you'll see your recovery seed and your wallet password. So these do need to be backed up. You need to write them down, take a photo of them, type them up somewhere and save them somewhere safe, because if you lose either of these, you can either not be able to unlock your wallet with the password, and you won't be able to recover your wallet if you don't have a recovery seed and you're setting up on a new computer. So just select them with your mouse, hit return, and that's now on your clipboard, and go and just paste those into somewhere secure. So if you've got some kind of secure note storage, stick them there or write them down on a piece of paper and put it in a safe somewhere. But yeah, you must make a note of the password and the seed. Okay, so now we're going to try unlocking our wallet. We've got our recovery seed and passphrase securely stored. So we're going to do an SPC wallet unlock. And we're just going to Control V to paste our password in, hit return. You don't get any confirmation, but what we'll do is type SPC again. And we can see our wallet is now unlocked. Okay, so next up we want to sort out the folders that we're sharing here. So if you remember, this is our 2 terabyte drive. So what I'm going to do is store 1 terabyte in data 1 and 850 gigabytes in data 2. So it's quite simple, just a few commands to run to do this. You can rename these as well if you wanted to. So for example, we could just call this data 1 TB and data 850 gigabytes. Whatever you want to do to actually make these as easy for you to understand as possible. I'm going to leave them as data 1 and data 2 for the time being. And this is just a matter of basically typing in SPC host folder add. I'm going to do p : / data 1 space and then 1000 gigabytes. Then we'll hit return here. We can see data 1 has been added. Now we're going to add in data 2. So if you press up on your keyboard, that will auto fill in what you've typed before. We'll change this to 2. We'll change this to be 850. So that'll leave us 150 gigs spare, one for the metadata, or 100 gigs for the metadata and 50 gigs just for the disk itself. So let's add that in as well. And we've now added in data 2. So now if we type SPC host, we can see, or get confirmation at least, as to what we're sharing here. So we can see storage being shared 1.85 terabytes. And we can see here the capacity of the folders that we've added. So this is all good so far. Okay, next up we need to define exactly how much we're going to charge for our storage. I'll put a link to this in the description, but basically this is the current recommendation for ScPrime storage providers, and they do update this from time to time. This was last updated on the 2nd of January this year. So be sure to read it for the latest recommendations, but we want to basically set how much we're going to charge for each terabyte of data. We then also need to set up the collateral, so how much is going to be risked. We also need to set up the contract length, so how long someone's data can be stored on your node for, and we're just going to set those up via the command line. It's just a few commands we need to type in basically. But it is really as simple as just reading through this, understanding exactly how much for your node you want to charge. I'm going to use the recommended defaults basically, but you can change them around if you wish. Just be aware that if you charge too much for your storage, then obviously people are going to be less likely to use it. Okay, so first up we're going to set the minimum storage price. So I'm going to set mine by typing SPC host config min storage price, and I'm going to charge 10 SCP for every terabyte of data that people use. Hit return. You'll get a message about the renter module. You can just ignore that. It's all gone through okay. You can see here host settings updated. So next I'm going to set the collateral as well. So SPC host config collateral. I'm going to set that to 10 SCP as well. That's the current recommendation. You can update these at any time as well, obviously. Just type in the new amounts as you see fit. Next we're going to set the SPC host config max collateral as 50 SCP. Hit return there. Next up is the collateral budget, so SPC host config collateral budget 2000. Then we're going to set the duration of the contract, so SPC host config max duration, and we're going to do 13 weeks, so 13W. Next up, we're going to set our download and upload bandwidth price. So SPC host config min download bandwidth price. I'm just going to set that to 1 SCP. I'm going to be generous here. And then we're going to do SPC host config min upload bandwidth price. And again, I'm just going to leave that as 1. Okay, that's our storage provider configured in that sense. So we've got our different configuration settings for how much we're going to charge. Next up, we want to set up our DuckDNS application. And this is basically going to give us a host name for our storage provider so that if your external IP address changes, which mine does, mine's a dynamic one. So by the time you're watching this, this will probably be changed. We want to have a name that we can point the ScPrime servers to so that it knows where to find our storage provider. So if you saw my previous video, we set up one called hexcrypto.duckdns.com. So we're going to set up another one now. Now, if you have a static IP address, you don't need to worry about this part. But the majority of people probably don't have a static IP address, so just follow these steps basically. Once you've logged into DuckDNS, you can basically add a subdomain. So I'm just going to call this hexcrypto2. You can call it whatever you like, obviously. And just going to add that domain in. So we can see here hexcrypto2 has been added to our account, which is great. So now what we need to do is actually download and install DuckDNS. So I'm going to click on install here. Okay, so on the install page, what we're going to do is click on Windows PowerShell. Now it's a bit scary maybe for some people, but we need to make this a script so that if our server reboots or our computer reboots, it will automatically still run in the background via the Windows task scheduler. So we're going to select Windows PowerShell, and then it's going to just ask you to choose a script here. So we're going to choose the top one here. It's been tested in Windows 8. So let's click on here. So the link on the DuckDNS page doesn't actually work, so I'll stick this in the description as well. So this is the code that we need, and it just gives you all the details of what you're going to be doing here. So we're going to basically copy this code. So just select copy. Okay, so we've got our script copied now, so we're going to go into Microsoft PowerShell, and we're going to click Start and just type ISE, and you'll see it pops up here. Right click on here, and we're going to run this as administrator. Just click on yes when it pops up. Okay, so we're now running PowerShell as an administrator. So what we're going to do now is paste in the code that we've just copied from GitHub. I'm just going to do a save as. I'm going to save mine as enable DuckDNS. Okay, so now what we can do is basically use this script to set up a scheduled task on our system to automatically update our DuckDNS IP address every 5 minutes or however many minutes you wish to set it to. So we'll find here, if we click on play, we're not going to be able to run this yet because our execution policy on Windows by default is restricted. We can have a look at that by just typing get execution policy. We can see it's restricted. So we want to set it, so set execution policy to unrestricted. And that will allow us to run this script. Click on yes to all, and we should now be able to click on play here, and the script will run. So it's going to ask us for the domain, so we created hexcrypto2. So next it will ask for your token, so go back into your DuckDNS dashboard, make sure you're logged in, and copy the token from the DuckDNS page, and then we're going to paste it into our PowerShell window here. Just press return again. And you can see here we get a confirmation that our DuckDNS will now update automatically, and it will continue to do so across system restarts. So the benefit of this over the GUI version, which you could install, is that you don't need to be logged in. It will just carry on in the background without having to worry. So we can actually have a look at the scheduled task it's just created. So to do that, click on start, type in task, or tasks even, and in the task scheduler, right click, run as administrator, and we can expand this, expand Microsoft, expand Windows, and scroll down to PowerShell, and then scheduled jobs. And here is the job that was scheduled by our script here. So on the system startup, it's going to start, and then every 5 minutes, it will just continue to run the update. Okay, so we're happy that our system is pretty much prepped up now. We haven't got any money in our wallet yet, but we'll do that shortly. What we do want to do is check the Windows firewall and make sure we've got all the ports open required for our system to run. We can close out of here. We can close the PowerShell now. We don't need that anymore. So in your command prompt window, you can just type wf windows firewall.msc, hit return, and that will bring you straight into the Windows firewall window here. So we can see that SPD has already opened up the firewall ports required. We can see here it's allowing any to any from public. You can lock that down if you wish. It may be worth doing if you're worried about things. You do only need a few ports open for this. So we're happy that Windows Firewall is all looking okay. So we'll look at our router now and make sure that's configured as well. Let's just check our IP address here. So if we do an ipconfig/all, we can see we have DHCP enabled set to no, so that's good. This is a static address for my computer here. So make sure you give yourself a manual IP address on your network, because we don't want the IP to change if the system reboots or if you get allocated a new IP address. So it's quite easy to do that. You just right click on your network icon and go to Open Network and Internet Settings. You'll then see your Ethernet cable, hopefully. If you're doing it on wireless, you'll see your Wi-Fi adapter there. But we're going to click on Properties here. I'm going to just scroll down a bit and click on Edit. So I've set mine to manual, as you can see, rather than automatic. So mine's manual. I've given it an IP address. You'll have to check your own local network to get the correct IP subnet for your home network. Mine is on a 192.168.1 subnet, but yours might be 10 dot something or 172. So the best way to check is basically to do your ipconfig/all, see what IP address you have currently, and you can either reuse what is already been given. If this was on DHCP and it had been given a 134, I could have just come in here, set it to 134 and click save, and then we'll know that it's always going to be on that same IP address. This will help for when we go into the router and actually do some port forwarding. So using the default ports, this is the sort of setup you'll want. So you want to enable port 4282 to port 4283, and you'll also want to enable port 4285. So once you've allowed those through, you can check. There's a good site here called Can You See Me? And basically you should see a success message saying that they can see the port open. Now, the computer I'm using here is on my other internet line, so it's actually my 14282 port, but yours should be 4282 or 4283 and 4285. They should all be accessible and available. So as long as you get success with those ports, then we are one step closer to being ready to announce our node. Right, so let's go through topping up our wallet with some SCP, because we need to have some collateral ready for our first contracts. So we don't need to put the full amount in to start with. We can put in enough for, say, 1 terabyte. And with the settings we've already configured, we'll need about 50 SCP for our collateral. So this will be just for our first terabyte of data. So like I say, you don't need to cover the whole amount of storage. You don't need to cover collateral for 24 terabytes worth, because at the start you're not going to have 24 terabytes of space in use. So here's SCP at the moment. It's had a huge increase since my previous video. It's just over $1 before. It's gone up to nearly $2, and it looks like it's gone well over $2 actually earlier today as it happens. But what we'll do is use South Exchange. I think that's the only one that's actually recommended. I wouldn't use Probit. I've heard lots of problems from people with that. So yeah, use South Exchange. I've put a link down below. It's not an affiliate link or anything. It's just a link to the site. You'll need to obviously sign up and get yourself an account. But once you have done that, I would go to Markets, click on Stable, and then in this list, just scroll down until you can find SCP USDT. Now I'm converting, or I have converted my USDT into SCP. You can obviously do it with Bitcoin or anything else if you wish to, but I just find it easier to transfer USDT myself. So what you would do is obviously transfer USDT into your South Exchange account, and then you would just come down to here, click buy, put in say 50 SCP that you want to buy, and it will tell you it's going to cost 96 USDT. So you then buy that, and it will end up, if we click on wallets, in your SCP wallet here. So you can see here I've got 70 SCP. So I'm going to send this across to my new node, and we'll just watch it come through and just confirm it all goes through successfully. So we need to know what address we're sending our SCP to. So let's type in SPC wallet address, and this will just generate an address for us to send to. Highlight this with our mouse, just left click and hold, hit return. Then we're going to come back to the South Exchange here. I'm going to click withdraw, and it's going to ask for the destination. So I'm going to just paste that in there, and we can quite easily just compare and just double check that has gone through successfully, or correctly at least. Just check the address looks okay, which it does. Now I'm going to send a test amount first just to make sure it goes through. So I'll send 10 SCP to start with. I'll put in my two-factor code, and then we're just going to click withdraw. So it's going to ask you to confirm that you're going to withdraw this. We're going to pay a bit of a fee here. That's pennies basically, well, less than a penny. And we'll click yes to continue. We'll then get an email that we need to confirm with. So in your email, just click on the link to confirm the transaction. And the withdrawal has been initiated successfully. So now we can just type SPC wallet. And we'll see that there's a confirmed balance of 0, and there's a 0 unconfirmed delta. So in a few moments, we should hopefully see this update with an unconfirmed delta. And then once it's confirmed and gone through the system or through the blockchain, we'll have hopefully 10 SCP arrive. Okay, so I've just run another SPC wallet, and we can see that the unconfirmed balance is here. So we know that that is the correct address to send to. So I'm going to send the rest of my balance across now. So I can paste in the same destination as before. And we're going to do the next 60 that I've got here. And then again, click withdraw. Click yes. And then just confirm via email again. Okay, so we've confirmed the other 60 to go across. So we can come out of our email. And now we can just sit and monitor by typing SPC wallet and just waiting for the confirmed balance to appear. Okay, we can see our unconfirmed delta now is 70 SCP, so we're pretty sure that that's going to be going into our confirmed balance at some point soon. So in the meantime, I'm just going to work on the startup script that we're going to create so that SCP will start up automatically if your computer restarts. Now, you could start it up manually by going into the command prompt and typing in SPD and pointing it to the right metadata folder, but we want it to start up if we're out and the computer restarts, or if there's a Windows update and it reboots itself. We want it to all start up automatically. So what we're going to do is create a little file and give it a few details which will allow it to start SPD and unlock the wallet. Okay, so I've gone into Notepad here. You can use any text editor that you have, but Notepad's nice and simple. And this is how our file is going to look to start with. So we're going to set the ScPrime wallet password here. We're going to paste in our password that we got from our wallet when we created it. And then we're going to start spd.exe, which is on our P drive in ScPrime, with the -d option, which points to the metadata. and then the minus capital M GCTWH. So all you need to do really is copy this, change around your folder path or your drive letters if you need to, and paste in your wallet password. Right, so once you've got your wallet password in there, we can do a file and then save as. We're going to save this on the ScPrime disk here, and we'll save it inside the ScPrime folder. Now we're going to set the file type to be all files, and we're just going to call this start scprime.bat. Click on save. You can close your notepad file now, and we'll just quickly check our wallet to see how that's going. Our balance is now confirmed, so that's good. But we're going to carry on with our startup script here. So we're going to go back into the task scheduler. So if you remember, right click task scheduler and run as administrator. Okay, now we're going to create a new task. So we're going to click on create task on the actions, and we'll just call it start SCP service. This will start SCP when Windows boots up. So we want to make sure that we run this whether the user is logged in or not, because we don't want to have to log in to our system to actually get this running. And we're going to run it with the highest privileges. So the triggers on the next tab, we're going to click a new trigger here, and where it says begin the task in the drop down list here, we'll just do at startup. So we'll just click OK. So we can see here at startup or at system startup, then the action we're going to perform on system startup, we're going to create a new one, and the action is going to be start a program. We're going to browse, going to go to our ScPrime disk, go inside the ScPrime folder, and just double click on the ScPrime.bat or the start ScPrime.bat that we created earlier, and then we're just going to press OK on here. So the conditions are all fine. We're going to click on settings next. So we can allow the task to be run on demand, that's fine. We're not going to stop the task if it's run longer than 3 days because we want it to always be running. So we're going to untick that one there. And we can untick this one here if it does not end when requested, then force it to stop, because if there is a problem with the task we want to, or SPD, we want to shut it down ourselves. So we'll leave this here. We don't want to start a new instance if the task is already running. We don't want to run it more than once. So we're going to just go back to the general tab here, and what it's going to ask for when we click OK is the password for our user account here. So it knows it can use this account to log on and basically start this task. It's going to press OK. Don't forget you will need to be an administrator of the computer to be able to do this. So make sure the account you are using for this is an admin. If it isn't, you better give it admin privileges, and then you'll be able to continue. You pop in the password and press OK. And that is ready to roll at system startup. So before we announce our node, what we'll do is just reboot the system here, and we'll just make sure our SPD starts up automatically and unlocks the wallet. So I'm going to restart now. Let's close this window down, let it close down properly, and we'll just do a restart. Okay, I'm just logging back in now. The system's just rebooted. So I can monitor on Task Manager exactly how things are going. It'll take a while for it to start up fully, but we can see it is running, so that's a good start. So let's open a command prompt window and just check the status. So we're going to go to the P drive and go to the ScPrime folder and just put SPC, hit return. We can see here that we're synced, the wallet is unlocked. We can do an SPC host. So the connectivity, it's still checking the status. We haven't actually announced it yet, but we can at least say that our host is restarting automatically without us having to do anything. Okay, so our host is now looking good. Nobody's connecting because we haven't announced yet. So we can now do the announcement. And all we have to do is type SPC host announce. Then we put in the DuckDNS name that we created earlier, which was hexcrypto2.duckdns.org. Then you put a colon, and you put the port number, which is 4282. Just hit return there, and the host announcement has been submitted to the network. So it's also been configured to accept contracts now. So we could use this command if we're not quite ready yet to basically stop accepting contracts. But let's just type spc host here. And we can see here now, we're now announced as this. And now all you need to do is actually go onto the Grafana website and actually check and wait for your host to appear. Now it can take some time. It can take around a day or so to appear sometimes. It just really depends on how busy it is or if they're doing any maintenance on the system. Right, next up we need to talk about backups. So we need to keep a copy of our metadata folder backed up somewhere safe, because if it does become corrupt somehow, you could lose all your contracts and then you'll be losing collateral on those contracts that you've got. So what I've done is create a couple of scripts here which will do the job for us. So the first one here is going to back up the metadata folder itself. So here on our backup drive, the USB flash drive, we've got folders. So we've got the backup folder here, and we've got an archives and a metadata folder. So I've put the scripts in here as well, but I will leave these in the description if you just want to make a copy of it. So what I'll do is just walk through the scripts and tell you how you can set them up on your own system. So basically anything inside the variables section here is something that you can change. So if you've got a different drive letter or a different folder location for your metadata, you can obviously change the source metadata location here. If you want to send it to a different location, you haven't got a Z drive maybe, you're sending it to something else, then just update this location here. And this is just a location for the log file to go, so I'm just storing it on the drive itself. But you can just check the log to see the last backup details, just in case you need to look back historically. So what this will then do is run a program called robocopy, and it's just using the source and the destination that we've defined above. It's going to mirror the directory, so anything that's in the source will be exactly the same as the destination. We'll have 10 retries because the default maximum is 1 million, which is a bit too long. And then we'll just write it to a log or append to a log in the log file location. So this is a script that we're going to want to run multiple times a day, probably, maybe 4 or 5 times a day. We'll set that in our schedule shortly. But that is doing the actual main backup of the metadata folder. So the other script here is an archive backup. So what we want to do is we don't only want to copy the metadata in here, we want to also create a zip of this folder and then stick it in this archives folder just for archive purposes. So basically if you were copying across metadata which was corrupt on your source disk, then you'd be able to go into your archive, and if you've caught it soon enough, you'd be able to use one of your archived zip files of the metadata to restore back onto your system, or ScPrime drive at least. So what this script is doing here, again, we've got variables that you can change in between these 2 points here. So again, we've got a source for the archive, so this will be the metadata that we backed up from the ScPrime backup script, and then the destination for the archive. So this is just Z backups archives in my case. Again, we've got a log file for the actual archiving itself, and then we can set the number of days of zips that we want to keep. So for example, if you want to keep 2 weeks worth of zipped up archives, then change this to 14. If you want to keep less, then obviously change it to a lower number. I'm going to leave mine at 7 because I'm hoping within a week of my node not working, I would have found out and been able to sort it at least. But basically all this does is make a archive or a zip file. I have got no compression turned on here because we don't need to compress database and things. It's going to just take forever. We've got plenty of space and we can monitor the space over time to make sure it doesn't fill up the disk. But basically all we need to do is set the path for the source, which is obviously defined up here, set the path for the destination, which is then defined under here, and we'll add the time and date just so we've got that added to the file name, just to make it easier to determine when the archive was taken. So if you do take more than one archive a day, then this is going to be very useful. And then we'll just add a metadata archive to the end of the name of the zip. After that, the script will then check in the destination archive folder to see whether any objects are created prior to 7 days, as I've set up here. And if they are there, it will then remove them. So anything older than 7 days, it will remove. So that's all this script does. And it will need to run at a different time to the ScPrime backup. We don't really want them to run at the same time because that will just be a bit messy. So we're going to schedule these now to run throughout the day, set different times, and get them running hopefully in a nice order. Okay, so let's load up the task scheduler again. And again, we're going to right click it and run as administrator. Okay, so in here we're going to create a task, and this is going to be our metadata backup task. So let's say ScPrime metadata backup. This will back up the metadata folder. We're going to run it whether the user is logged in or not, and run with the highest privileges. So under triggers, we're going to create a new trigger here, and we're going to run this on a daily schedule, and it's going to recur every day, and we're going to repeat this back up every 4 hours. I'm going to set the duration to be indefinitely. We're going to tell the task to stop if it's run longer than, let's say, 8 hours. We're going to keep it as enabled. So the first time we want to run this, I'm going to set this to be 10 AM. So at 10 AM, we will have our first metadata backup, our automated one. And then every 4 hours after that, it's going to carry on running the task again. Okay, and then the action we're going to select here is going to be a new action. And we're going to start a program, and we're just going to type in here PowerShell.exe. And we need to put some arguments in, which is where our script is going to be located, basically. So these are the arguments we need to set up for the script to run. Now, again, I've saved mine on the Z drive here, just on the root of it. So if you've saved yours somewhere else, you'll need to use obviously different locations, but this is mine. So I'm going to stick this into my add arguments here, click OK. Under conditions, we can skip this and then go to settings. We can allow it to be run on demand, so if you want to do an on-demand backup. Again, we're going to stop it if it's running more than 8 hours and leave this as do not start a new instance. So we're going to click on OK, and like we did before, we're going to have to put in our password for this account. And now the metadata backup task has been created. So let's create the one for the archiving as well. It's going to be very similar to the last one. ScPrime metadata archive, archives the metadata folder. Run whether logged in or not, run with the highest privileges, triggers, new. So let's get this to run daily at, let's say, midnight. We don't want it to ever conflict or have a chance of conflicting with our metadata backup. So we'll run it off, 30 minutes past the hour, and we should be fine. We won't bother stopping the task because it could get to a stage where we have got quite a big archive being created and we don't know how that's going to grow in the future. So we'll leave it for the timing to not bother stopping, and we'll keep it as enabled. So every day at just gone midnight. And then the action, you've probably guessed it, we're going to create a new action, PowerShell.exe, and then we're going to specify again, this time our other script, which is called ScPrime Archive Backup. So we just copy that into here and press OK. Skip past the conditions. We will allow it to be run on demand, and we can probably leave this one ticked. If it's running longer than 3 days, then we probably know something's wrong. So press OK on this. Again, we'll put in our password. And we've now got both our scripts set up and ready to keep our metadata nice and safe. So I do recommend you test your scripts, obviously, to make sure that they're functioning. I have just kicked off an archive of my metadata backup, which is already completed, and we can see that's now running. We've got another couple of gigs to go, so that'll take some time. It's also worth now setting our execution policy back. So if we just do a get execution policy, we can see it's unrestricted, so we're going to set execution policy. We'll leave it as restricted because our scripts are going to set it to be bypassed whilst they're running. So we'll leave it restricted unless they are running themselves. So we'll set that back. Click yes to all. Okay, so let's say our provider is doing really well and we've got our storage getting nicely used up, and we want to add in our additional disk now. So if you remember, we've got an 8 terabyte disk, which I've just turned on. So we've now got 8 terabytes of additional space that we can add. Now we don't have to add the whole thing, but we can if we wish. So we'll just go through adding those additional folders. As you can imagine, it's very similar to before. We're going to create some data folders in here. We've got drive compression. We will double check that, make sure that's enabled. It's not yet, so let's enable drive compression first. Press OK and apply. Click continue. We've got compression enabled. So now what we're going to do is go in and create our data folders. So let's create these slightly different to the previous drive, so it might make it a bit easier for people. Let's call this one 1 terabyte A. We'll have another 1 terabyte B, 1 terabyte C, and 1 terabyte G. So those of you who are good at maths will realise this is going to be 7 terabytes worth of data. So the next folder we're going to create is not going to be another terabyte. We're going to just create an 850 gig one. So 850 gigabytes. And we'll just leave that as it is. So these are our folders. Again, call them whatever you want, whatever works best for you. This is just what I'm going to use during this video. Okay, so we're going to set up our new folders now that we've just created. So we're going to do the SPC command, host folder add, and then don't forget you can always do a /? if you can't quite remember the syntax for the command. So we're going to put the path and then this size. So the path is going to be our S drive. So up on the keyboard, just delete this. So we're going to have S : /1 terabyte A, and this is going to be our 1000 gigabytes. Hit return, and we'll see that 1 terabyte A has been added. If you press up on your keyboard, we can quickly go down, add B and C, and I'll just skip to once I've finished setting these all up. Okay, so I've gone through my folders now, so we can minimize this and we'll have a look at our SPC host. And these are our folders that we have just added in. So you might want to remove a folder if you've decided that you don't really want to actually use as much space. So it's quite a simple command. Instead of folder add, we're going to do a folder remove. We're going to try removing the 850 gig, for example. So S : /850 gigabytes. And we've removed that folder now. We'll try removing one of the 1 terabyte folders as well. So let's go for 1 terabyte G. And that's also been removed. So let's do an SPC host. And we can see now we've gone down to about 8 terabytes. That's it really. It's quite easy to add and remove folders. You do need that additional space on the drive though to be able to move things around a bit. So don't forget, don't use up the whole space. Leave some space free, at least 150 gigs I'd say. Even if you're not going to store your metadata on there, it's just worth having that extra breathing room just in case. So that's it really. That is the setup of an ScP storage provider, and if you've got any questions at all, do leave them down below and I'll try my best to answer where I can. I did have thousands of messages from my previous video and I haven't been able to keep up, so apologies if I didn't get back to you. I have tried to get back to everyone. Now, earnings on these ScPrime miners are a bit of a sore point I think at the moment for various reasons, but I've been earning about 20 ScP a month with my original node, which had no data usage but it met all the incentives. So $20 a month with no usage I thought was quite nice. Now, if you're charging 10 ScP per terabyte per month, then you can kind of work out how much you could potentially get if your drive was full up. Now, don't expect your drive to fill up quickly or even at all, because when you think about all the other providers, the data is going to be spread out amongst multiple providers, and not one person is going to sit there with 10 terabytes of data on their own. It's going to be spread out amongst various different nodes on the network, and it's very unlikely you're going to end up with a full node. So the price of ScP has rocketed up recently, which is good to see. Obviously it's good for the project, but yeah, don't go in this thinking that you're going to end up earning thousands of dollars a month from your ScP, because you're just simply not. It's not going to work like that. So be realistic. This is just a fun project to be a part of. Make sure that your node is in good condition and that you keep it working and running nicely, because I have heard rumours that the Raspberry Pi nodes could get blacklisted depending on their reliability, which is completely understandable. They don't want to offer a service to businesses which is going to be a bit flaky. They want the best possible. So the equipment here that I'm using in this video is pretty good, I'd say. We've got our quad core, 8 gigs of RAM, we've got our SSD on the system, and we've got backups of our metadata just to keep things nice and safe. But if you are going to go into this project, go into it with an open mind. Don't go into it thinking you're going to become a millionaire, because you're just simply not. As nice as that would be, I'm sure everyone on the ScPrime team would like that, but it's just not going to happen. But it's a nice little project and I think it's going to do quite well personally, but only time will tell. It's going to go live before the end of January, so it'll be interesting to see how things go. I'll continue to make updates when there's a good update to come out with, so we'll see maybe in a month or so how things are going. But yeah, if you did enjoy this video, please do like and subscribe, as that really helps out. You can also become a member of the channel by clicking on the join button. And again, thanks for watching, and I'll see you in the next video.